Hello everyone, welcome back to the channel. So I actually found some video from the UW APL Applied Physics Laboratory and how they were assisting OceanGate when they were developing Cyclops 1. This document is a proposal from the Applied Physics Laboratory that was sent to OceanGate, pretty much just presenting to them the experience that they have and how they can help OceanGate when they're doing testing for their quarter scale model. When they did the scale model for the Cyclops, it was actually a quarter scale, and it was going to take a few years of testing, and the Applied Physics Laboratory is going to help and assist OceanGate build and develop this. We know that the APL denied having involvement in the OceanGate Titan, but they definitely helped OceanGate build Cyclops 1. Here is the total amount that they're requesting. So they're pretty much saying to help design, build, and test this submersible, it's going to cost about $5 million, and that's what they are charging OceanGate to use their facilities and to do all the testing. So here it says that they're going to be working with OceanGate to provide test and analysis of system components in the integrated system. This is a 3-month schedule, so it's going to take about 6 months to design it, and then we're going to be working on the hull, the dome, interface ring, and how that's going to work, the system architecture, and then the launch and recovery system. So it wasn't just OceanGate that developed that system, but it looks like the APL UW also had a hand in that. And then from month 6 to month 27, they're going to be working on the entire system design, and you'll see that here in the video shortly, as well as a mock-up fabrication. So pretty much building prototypes and quarter scale models, and then they're going to begin to build the full size model here in about month 21, and then they're going to test and validate everything, ensure that it's ready and operational. And this just goes through some of the staff there. Dave Dyer, you will hear from him shortly. It seems to me that he actually came up with the idea for the Bluetooth controller.
OceanGate, a for-profit private company in partnership with the University of Washington's Applied Physics Laboratory.
We couldn't have done it without that partnership. You know, the Applied Physics Lab has been effectively our engineering partner.
APL UW's David Dyer explains how the lab works with OceanGate.
We had to get creative on how we can actually pull this work off and be able to have a reasonably priced project output for OceanGate.
The key, APL provides brainpower and skills as needed.
So we've been able to move people in and out of this project, and that's what got back to one of those financial challenges on there. Is how do we get Stockton all the expertise he needs in an affordable manner so he's not having to carry this huge overhead on this project. So we can bring someone in and charge a couple hours to it and let them go off and they go back to their own projects and their own work on that.
APL UW scientists and engineers faced some major challenges, starting with how to design a deep diving submersible that you don't have to be a U.S. Navy submarine skipper to operate.
Stockton is very interested in being able to quickly train pilots, have pilots be able to come in and use this thing without having to go through weeks of training on there.
Solution? This video game controller.
Combination steering wheel and gas pedal, which is this device. This is a Sony PlayStation PS3 gaming controller. And with this device, we can drive the submarine, make it go up, down, left, right, forward, and backwards. The main challenge probably was learning how this device communicates with a computer.
APL's Pete Brodsky designed the Cyclops control system and the complex electronic paths from the controller to the submersible's thrusters.
In a nutshell, the electrons from here have to make it through about 10 different channels of a computer, out fiber optic, into another device, which turns it into an analog signal, out to a motor drive, which then generates high-power electrical signals out to the thrusters. Getting all that connectivity right was interesting and challenging, but we believe we have it down now.
There's aspects of it that are groundbreaking.
David Dyer tackled the impact of hull design on efficient energy use, developing an evolution from earlier, boxier OceanGate submersibles.
When you look at the Cyclops shape, there was a lot of effort put into it to make it look neat and cool, but also to make it so that it was functionally hydrodynamically efficient.
Efficient without compromising the pressure hull.
We are now taking a pretty significant exoskeleton structure, having to attach it to the primary pressure hull.
That's good. Come on in. I think we can push it over.
You can't put holes in it. We didn't want to weld to it. We had to do it in such a way that we didn't impact the functionality of that pressure hole. So technically, that was a big challenge for us.
With Cyclops nearing operational status, the next step is the marketplace. The basic pitch:
Cyclops is going to be a very useful tool for any organization, company, or institution that needs to go underwater and perform tasks at depth without requiring a very expensive support ship and other apparatus that would be associated with a remotely operated vehicle.
To get the word out, a Cyclops roadshow is planned.
It's going to include dives in the Gulf of Mexico, off the East Coast, and off the West Coast, as well as dives here in Puget Sound.
And expect media events along the way, similar to Seattle rap star Macklemore's dive aboard OceanGate's Antipodes submersible for the Discovery Network. The spotlight will be on Cyclops, product of the partnership with APL UW that made it happen.
If this thing makes it, and if this thing goes off and it starts becoming a big deal, it's actually a model that we can then hold up and say, look, this is not something that only works for OceanGate. This is something that will work for other people and get them help on getting that up and running and move off and become an impact in the economy.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.
And then the remainder of this document is just resumes, and then it breaks down a per year schedule of the costs here. So here you can see for the full 3 years is what they're anticipating. Just in salaries, they're anticipating 1.2 million in salaries, 740,000 in employee benefits. Must be nice. And then they've got equipment, travel. What else do they got here? Indirect costs, things like that. So for the full 3 years that they're going to be developing this, they're anticipating it costing approximately $5 million. This is from the UW APL, and this is the Cyclops. So they have a quarter scale model. So this is the quarter scale hull pressure test. It says the objective of this test is to validate the pressure vessel design is capable of withstanding seawater pressure corresponding to operating in the ocean at a depth of 6,000 meters. The pressure vessel configuration is shown in figure 1. Pressure vessel material is fiber spun carbon fiber with stainless steel interface rings. So remember, going back to the original idea for the Titan, the ultimate design that they wanted to develop was going to be a fully carbon fiber design. So remember that, so the titanium end domes, they were actually hoping that those could be carbon fiber, and they would still have a viewport in them, but we're going to see why that wasn't such a good idea here shortly. Now it does say as well that they are installing strain gauges and they are being monitored during the test. And this is pretty much the pressure or the testing schedule, the dive schedule for this pressure test. So the first stop is going to be at 100 psi or 68 meters, and then they're going to hold it for 5 minutes, and then they're going to continue building pressure inside of this testing cavity, and go down to then pressurize it to 342 meters, hold it for 5 minutes, and they're going to keep doing that for 5 minutes. The first significant stop here is at 4,000 psi, which is at about 2,700 meters, and they're going to hold that for 10 minutes. And then the next significant stop after that is at 4,000 meters, and they're going to hold that for 10 minutes. Now, 4,000 meters, that's past where the Titanic is. The Titanic is in 3,800 meters. So that would be sufficient enough. And then, so they're not just going, so they're trying to rate this for 6,000 meters. So they're doing 6,000 meters plus a safety factor of about 10%. So that's going to be 6,600 meters, and they're going to hold that for 15 minutes. And then to depressurize the chamber, they're going to make 4 stops at 6,400 meters, 4,000 meters, 2,000 meters, 68 meters, and then bring it all the way up or depressurize it completely.
At the University of Washington in Seattle, the first test of a scale model of Cyclops' new filament-wound carbon fiber hull, designed and manufactured by Spencer Composites in collaboration with OceanGate and APL UW.
We're testing a 1/3 scale model of the pressure vessel that will be used on Cyclops 2. The pressure vessel consists of 3 parts, a cylinder and 2 hemispheres. One of the unique elements of this test will be the hemispheres. So the hemispheres are also carbon fiber, which has never been done at this size or to this depth.
The goal of this test, pressure of 6,000 pounds per square inch. Pressure is raised gradually. At the 71-minute mark, the pressure increased to 4,000 pounds per square inch. At 72 minutes, the pressure was turned up to 5,000 psi. But 3 minutes later, at a pressure of 4,285 psi, representing a depth of about 3,000 meters, the test was aborted by apparent water intrusion into one of the carbon fiber domes.
Yeah, she's open.
That is the most risky part of the test and the most difficult to analyze. Since it's never been done, there's no test data on how carbon fiber in a hemisphere will respond to the pressures.
This initial test was deemed a success at 4,000 psi, the equivalent of 2,800 meters.
And then here is the actual testing log. And you can see here all the stops that they made. This is the PSI, and then you can see here once it got to 6,500 meters, it says that there was a pressure sensor gone, or it just became disconnected, but it was a failure for that test. So that test is pretty much no good. They can't use that because the sensor failed. And then once again, they're doing a pressure test here. And then once they get to 5,800 meters or 5,500 meters, it says that one of the pass-throughs began leaking. This is in the carbon fiber dome, and you guys will see how they spun that, but they spun a sphere of carbon fiber and then cut it in half, and that's what they're using for their carbon fiber domes on the end. Okay, so once again here, they are beginning to pressurize, and the end caps are leaking once again. And then this is one of the implosions. This is in March 2016, where the carbon fiber hull with carbon fiber hemisphere end caps, so they pressurized it and then the end cap imploded. So they could have damaged something during that implosion, right? We understand the difference in pressures and how much of an impact that can be inside of a pressurized vessel or pressurized chamber. And it says here that, yeah, this is just their charges for cleanup and test, cleanup and repairs, cleanup equipment. It says the good news is the pressure sensor is fine. That is actually an $8,000 part. So saved them some money there. And it looks like here they're just talking about getting some ice from QFC or Safeway in the morning. And I believe that they're going to lower the temperature inside of the pressure chamber just to simulate real world conditions and how the temperature could affect the carbon fiber. Now here again is something interesting. So it says high and redacted. So because this is an extremely busy time of year for us, we cannot afford to have any downtime with cleanup or repairs to the pressure vessel. So saying that, hey, you know, if you guys have another implosion, it's going to prevent us from performing work. We're too booked up right now. We can't allow that to happen. And then what they're saying is that there's likely going to be an implosion. You're likely going to pressurize your scale model until there's a failure or an implosion. So to help mitigate damage to the chamber or any sensors or anything like that, they're just requesting that they fill the scale model with wood as much as possible. And then also they are going to wrap the carbon fiber, the entire scale model, in a fabric. And so what they're using is actually like black landscaping, like ground fabric that you can lay down, and they actually wrap it in that and then hang it inside of the vessel to catch any debris. So these photos here are from the Polar Prints. They provided these photos to the U.S. Coast Guard. They're not helpful for trying to figure out what went wrong with the Titan specifically, but they do give us a very good insight into the entire layout, what it was like on the ship, the operations. So I think that these are pretty fascinating. This is just a nice wide angle view here of the Polar Prints. Here you can see the skiffs that they have on board here. And when they're ready to launch these, they'll just pick them up with the crane and drop them in the water. Now remember, the Polar Prince doesn't have a ramp in the back, which is why they had to tow the Lars for hundreds of miles in the open ocean. So I'm quite amazed. They actually provided some very high definition photos here, which is awesome. This is awesome for us. Okay, now this was also provided by the Polar Prints. They have some visuals that they provided as well. So here you can see their actual route that they took from May 11th to June 18th. And this was Expedition 2023 Mission 1. This is May 12th to May 19th. And we can look at the dive logs and cross-reference that. Now, these are the dive logs for the OceanGate Titan. Now, the funny thing is with this entire time, even though we know that they had a separate hull, they're just counting all this on a single dive log, and they're treating it as if it was one vessel. This is two different vessels that they're trying to act like it's one, because the initial hull was struck by lightning. They had to decommission it. They built a new one in 2020, and then they were diving the second hull when the implosion happened. So all of their maintenance logs and all their dive logs, they're just treating it as it's one vessel, but it's not. I mean, in what world do you have a vessel, it fails, you reuse a bunch of spare parts off of it, and you consider it the same vessel? Like, no ship does that, no boats do that. I know there's a lot of superstitions in the marine industry. To be quite honest with you, that was not appeasing the gods, if you know what I mean. Okay, so what we're looking at here is they got the dates right here. So it starts all the way back in 2018 with the original vessel. And then they got the dive number, dive location, dive time in hours. This is in hours right here. And then the max depth, and then the pilot. The crew, for the most part, is redacted, but they do have dive objective. They do have risk index, which I'm not going to go into that. And then they have the payload here. The payload is going to be important for us because they provided the payload in the transcript, which we're going to look at here shortly, and what that final payload was. But here you can see the payload here is 1350, which is about 300 pounds lighter than what the payload was when the implosion happened. So let's scroll down to May, and we're looking here at May. This is en route to the Titanic. So this is weird. So 4 dives after the loud bang, and 10 months later, they're en route to the Titanic on May 22nd, 2023. They have a dive that is a half hour long, and it's 8 feet deep, and it says that it's unmanned. So I'm wondering if this was planned or not. So it says that it's a 419 drill, and for some reason there's no notes here. So I'm not sure what that was about. It says that mission 1 was from May 12th to May 19th, but we didn't see any dives from the Titan during that time. So I don't know if they had canceled dives or what. So, and then it says mission 2 was May 20th to May 28th. Now, this is en route to the Titanic. That's when we saw that it had an unmanned dive with a max depth of 8 feet. Now, they have some really good photos here of the Lars. This next one in particular, very high definition photo of the Lars. I haven't seen anything this clear or crisp. This is awesome to see. It really helps paint a better picture of the Lars and how everything looked there. Now here it says May 20th, departing St. John's. So they're leaving here on mission 2, and this is May 24th in the open Atlantic Ocean near the Titanic. And it looks like they're having issues here with the Lars, and it's taking on water, and they're trying to get it stable. Here's another photo from May 24th. So this right here is their maintenance log, and if we look, there's nothing here for the 24th. So we could see here on the 22nd when it was submerged for a half hour, that was unmanned, so it was likely just still on the Lars. It says that the tail cone was missing for the rear fairing, and there's a photo of that here shortly. But there's nothing here for May 24th, which I found to be quite odd when we clearly saw the Titan and the Lars going underwater. So now here the next day on the 25th, you could see that fairing is missing there for the tail cone. And then that little T right there is actually the syntactic foam blocks that are in there to help counterbalance all that extra weight that's in the aft. And it looks like the crew obviously is inside there working on something. That might actually be Stockton Rush right there. Now this is May 27th. They're clearly having an issue here with the Lars. This thing is completely tipped up with the Titan still on it. You have a vessel that weighs 25,000 pounds, and it's just being secured to the Lars by some bolts, and you got all that pressure that's leaning over, and I can only imagine how much stress that would put on the frame for the Titan. So that was on the 27th. And let's see if they have anything written down here. Again, no. Just some foam blocks missing. Nothing to do with the Lars. Isn't that odd? Nothing to do with the Lars. This log is for any issues that come up. Any issue that you're supposed to log it here. You're supposed to sign off on who you are, and then you're supposed to write down what the fix was that you did. You know, whether it was inspected and everything was okay, whether it was replaced and flushed. And then, so do you guys remember in the last video, I showed you guys the hole penetrations and where those were located and what those were for. We went through the OceanGate Titan manual. If you didn't see that video, go back and look at it. I have timestamps. I'll leave a link below. But remember, we were questioning if the hole penetrations actually was the source of the implosion. Because remember, it doesn't, just because the carbon fiber hole collapsed doesn't mean that that's where the implosion was. It could have been at the end of the carbon fiber hole. It could have been the acrylic window, which is still missing. It could have been one of the hole penetrations. Now, literally the day before the implosion, it says that there was a slow leak on the HPA line coming out of the hole penetration after shutoff valve. And then it says that the fix that they did, that this is the day before the implosion happened, is it was an NPT fitting and they tightened it 1/12 of a turn. So that to me indicates that it was loose to begin with and then they tightened it. Now, I didn't see anything else in here that mentioned the HPA line, which is the high pressure air line. That goes to their 10,000 PSI tank. Now, remember that tank is rated for 10,000 PSI. It holds 10,000 PSI, but anytime they use that, it's going to lower in pressure. So they can't actually use all of the air in that tank because it would implode, right? Now, I didn't see anything else significant on the maintenance log the day before the implosion, but they did have a lot of things to note here. So the antenna flag was missing a zip tie. Okay, whatever, not a big deal. That issue was still open, so they didn't do any maintenance there. So it says here, the sealant on titanium to carbon insert unsightly. And it says ground off bumps in sealant to make smooth surface. I don't know what the hell that means, but someone took a grinder and ground off bumps in the sealant to make a smooth surface. That just seems like a gung-ho shooting from the hip kind of fix. Like we're just going to take a grinder to life-saving equipment, which is, I don't know, that's pretty alarming to me. And then it says the VPT motor failed to go to vent. Remember, the VPT motor is inside of that open lift bag that we looked at last time. What they're calling the ballast. It pretty much has an open-ended exhaust hose that travels up and down inside of that lift bag, and it pretty much sets the level for how much air is going to be inside of that ballast, is the best way I can explain it. So how much air, if it's controlling the level of air, how much air is in that ballast, then it's controlling how much buoyancy the Titan has. Oh, and then what they did was motor suspected to have been damaged by pressure due to sealed housing. Melted hole in plastic of new motor, reassembled and installed, replaced motor with new motor. And then it says water spray from vacuum/vent port may spray on electronics, and then Stockton installed a tube to deflect the spray. So yeah, whatever, not a big deal. They're just blowing air out of that open-ended line, because remember, there's a switch where they have to create a vacuum. That's pretty much just saying any residual water inside of that open-ended line, when they need to vent it, then it could spray electronics, which is, that's fine. And then it says here that floor mat slid on dive 76. I think that they meant 86, dive 86, because the failure was on dive 87. And then it said installed 2 strips of Duralock at edge of mat near bay door. Need sight holes for pre-dive inspection of VPT level tube. So pretty much what they're saying is they need to drill holes in the fairing so that they can get eyes on the VBT tube that we were just talking about. Tracking system, they just needed to upgrade that. Okay, so moving on here. So this is Expedition 3 in 2023, May 29th to June 3rd. Now this is May 29th, St. John's Harbor. Here they've got the Lars set up. It's tied up alongside the ship here. And now this is departing St. John's Harbor. You can see that aft tail cone, the styrofoam, is still exposed. This is on May 29th. And then June 3rd, heading to the Titanic. They're in vicinity of the wreck site. And this is on June 7th here, St. John's Harbor. They returned, and it looks like, I don't know if they're doing drills or what they're doing here, but they're clearly in the harbor. I'm pretty sure that this is just performing some drills, unless they're having some major issues here. Now, this is June 11th, approximately 400 nautical miles to the northwest side of the Titanic wreck site. in the vicinity of Sable Island National Park. There's a better look at that syntactic foam inside of that tail cone. And this yellow thing right here, so we don't have any clarification on this, but I'm pretty sure that this is a compressor that's inside of a float so that they could use to recharge and refill up these tanks here. Okay, now Expedition 2023, Mission 5, June 16th. They're headed out from St. John's Harbor, and they are out here at the Titanic wreck site. Now, this is June 16th, heading out to what they don't realize is going to be their final mission. Here we have a good high-definition photo. You can see all these commercial fishing boats here in the background. Just a small little fishing town with this big research vessel here and towing out the OceanGate Titan there. And that's all that we have there from the polar prints and in the photos that they provided. Now, there are a few brochures here, you know, for the Bahamas and different places that OceanGate was taking tourists to. Let's face it, that they were tourists. Now, this one in particular caught my eye because it does provide some specs for the Titan submersible, such as it was rated to a depth of 4,000 meters, but rated by who? Rated by OceanGate. The weight of this thing is actually 25,000 pounds. So it's hard to imagine that, right? We always see this object and we just think that it's kind of light or like, you know, a few tons, but no, it's about 12.5 tons. Now this is one of the older brochures when they were still using the Horizon Arctic. Remember, they had a launching system back here. So they would launch the entire Lars system off the stern of this vessel. And the polar prints didn't have that. So that's why it got towed in the open ocean. And this is inside of the Horizon Arctic here. Very nice amenities. Now, when they were using that vessel, this is with hull number one. A lot of people have given me crap because I always say hull and not hull. Hull. So I'm trying to work on that, but yeah. Now, this was the original hull. This was the first hull for the Titan, and back then they were charging $150,000 per person, $150,000 a head. Now, this is the second brochure. This is with the new hull, and they're using the polar prints. Obviously, this operation is getting much more expensive. This is post-COVID, after inflation and everything has gone up. They're charging $250,000 per person to become a mission specialist. And then this right here is a brochure for the Titan itself. This one, it says that it's rated for 4,500 meters, when we know that it was nowhere close to that. And this photo must have been taken early on, because you could see that they have like these jimmy rigged weights down here. So these are lead weights, and they're using these to trim off. But look, they're just tied off here with like paracord or something. And they have these weights sitting there or glued on there. They might be glued on, but we don't see that other drop weight system with the steel pipes in there yet. Now, it says Titan is a Cyclops class manned submersible. Well, a Cyclops class, I mean, that's just their own classification. That's not by any agency or anything like that. Remember, this vessel was supposed to be called Cyclops 2, and they ended up calling it Titan, which, why in the heck would you name it after a massive tragedy like that? I don't know. You're kind of you're really just asking for trouble here. But in any case, so it says that it's 21,000 pounds. The payload for this, so that, remember, this is the maximum weight, just like a truck or a trailer. The maximum weight that it can carry is 1,500 pounds. That's important. So just remember that here. Now, this is the EvoLogics data. We're going to get to the payload and all that here shortly, but this is the EvoLogics data. This is communication that OceanGate had with the company that developed the acoustic modem, that developed the communications that OceanGate was using between the polar prints and between the OceanGate Titan. Now, it says that, hi, redacted and team, we have an emergency need for your assistance. Today, during a dive to 3,800 meters, we lost contact, no chat or tracking for well over 8 hours now. I'm assuming you have developer tools that can extract spectrum recordings and data messages. Pretty much they're really just looking for help, but I'll be honest, when I was reading this, I was pretty shocked that they're being so casual about this. Hey, you know, we have an emergency need, you know, we lost communications. There's no chat or tracking for well over 8 hours. I mean, first of all, pick up the phone, but second of all, I mean, I would definitely start off by making this seem a bit more urgent, wouldn't you? Now the other thing is the person who is sending this is in the office back in Seattle. They're not out there on the ship. So they're having to use a middleman between the Polar Prince, and then they're going to a middleman in Seattle back in the office, and then they're going over to this company that developed this. Now here they're just kind of going over the general dive plan and planned activity. But again, here, they're just being super casual about this. Like, here's an update for you at the end of June 19th. We really appreciate you jumping in so fast to help analyze data surrounding the loss of the tracking contact and verifying current tracking status. This was important information for the search and rescue efforts to begin. But, it's just like, it seems like they're just being so casual about this. It's just really frustrating to see something like this, because back when this incident did happen, it was like the entire world was just like counting down each minute for, how much supposed oxygen they had if there wasn't an implosion. And for them just to be kind of so casual, and we're just kind of sending emails back and forth, there's lots of chitter chatter. It's just frustrating to see that now, personally. So it says here that and remember, we've heard this before, that the drop weights should have been released after 24 hours. Apparently there's some sort of glue or some sort of mechanism that should have released 24 hours. And then it would have been a few hours of ascent time, and then they should have surfaced. Even if there wasn't an implosion, let's say that they lost comms or they lost all power and they were sitting on the ocean floor. Just from what we've seen, I highly doubt that this thing would be floating up at the surface, and they would have been able to see it. We went through the numerous flaws with the vessel in the last video, just simply by going through their operating manual. So it's just saying that the Navy has dropped the sono buoys, so it's multiple buoys, and then they're constantly using that passive sonar to try and pick up any sound. And so pretty much they're just reaching out to the EvoLogics team to try and pinpoint the exact last location. Then it says next steps related to EvoLogics assets. More than one ship with an ROV capable of reaching the bottom are en route. And pretty much they're just trying to figure out the location there. This is from the EvoLogics team. It says, please let me add a few points to the summary that might be important to take into account. Time difference between the last two text messages from Titan was 5 minutes. The Z coordinate change, this is the location, Z coordinate, change during this period of time is about 300 meters. Time difference between the last text message and the last position information is 5 seconds. According to the last message, we had to expect some changes in the location evolution. In the attached file, you can see a plot with Z-coordinate evolution, where it continues to increase linearly till the very last fix. As far as I know, Blank has already provided you with CSV files with the measurements exported from Synapse, which is their software system. And then currently we have agreed with Blank the checklist for the beacon reconfiguration for ROV mission. He is doing the preparation steps now. And then here it just says, thank you for the added insight, and of course your ongoing assistance. Thank you, Blank. The first ROV equipped ship has just arrived. We'll stand by and see what they want to do and when. And then this just saying that regarding the Z coordinate, the accuracy of that, they're just saying that, it should be within tens of meters of what that last known position was, which is a very narrow location, right? Like in the grand scheme of things, when it's 3,000 meters depth and you're dealing with miles and miles of open ocean, well, to be able to narrow something down that's within tens of meters is pretty impressive. And then this was pretty interesting. So the EvoLogics team was asking for the full CTD profile. So pretty much they're just trying to look at previous data, right? And then trying to like cross-reference that, and then just see if make sure that everything was calibrated correctly, or if there was any discrepancies, things like that. And then OceanGate's response is, we do not have the full data set for this year. The CTD is on the sub, and this was the first dive to Titanic this year, so the data is still down there. It says they only have data from previous years. which is pretty crazy that, you know, like there's only one location and it's on the sub. Like, what are you guys thinking? Okay, and then here's just additional information. I'm not really going to bore you guys with that. There's nothing, I went through it and there was nothing really alarming or nothing important to note there that I found. Now, what I did find was the actual transcripts from the dives. So in a previous video, we already went through the animation that the Coast Guard presented, and they did they did go through the transcript. It wasn't the official transcript, but it was pretty much the same thing with timestamps. Let's see. I need to get this to where it has the time. Okay, so this is the official transcript. Now we can see here that this is from June 13th. So this is prior to the dive. The dive began at 9:01 a.m. Newfoundland time on the 18th. That's when I believe they began their diving operations then. So I'm pretty sure that they were just doing some comm checks. And then at 9:19 is when they actually began the dive. Like they were just starting diving operations, getting everything set up at 9 o'clock, because that was their first text message that they sent to the ship. So it says, I have HSVR tracking, and then descending through 2:35. So this is when they actually began descending right here. And then it says, we see you at 33 meters a second. Now, remember the payload weight that we just went through? So it says that the payload for this is 1,500 pounds, right? Well, it says here, report your payload, your dive payload weight. And then it says 1676. That's over 100 pounds of what the payload says that it's rated for. At least in that brochure, right? And what they are claiming are the specs for the Titan. It says that it's 1,500 pounds, and here they're over 100 pounds heavy. So a lot of you, including myself, had questions of, were they overweighted? Were they just going too fast? Well, we can tell here they were actually pretty much on pace for their descent rate. And it said in the transcript that they're going 33 meters a minute. Now here it says that that the ascent rate is 35 meters a minute. So I think that they were pretty accurate with that. And I think we can kind of rule that out for a potential issue. However, ironically, they were overweighted. And then remember, the last message that we got from them was that they had dropped 2 weights. And so here we can just look at the times here. 10 o'clock, 11 o'clock, we lost tracking. Come back to your last position. We're turning back to close on your last known position. We're on your last known position. We lost tracking last 23 minutes, and then an hour later, looking for you, no tracking, looking for you, no tracking 51 minutes, no tracking 52 minutes, no tracking 53 minutes, looking for you. Expecting you to come up. Expect you are coming up now. Looking for you. 2 hours later, we've lost you. Assuming you are ascending. Looking for you north of last known position. Assuming you are ascending. Moving north of your last known. Report your depth. Report your location. And then it appears here that about 6 hours later, that was the last message that they had sent to the Titan. And then they did, up until the early hours of the next morning at 1:30 a.m., they did have this system on, but it didn't look like they were actually trying to make any effort to have communication with the Titan anymore at that point.